So, as a high school science teacher, it is my goal to have my students so excited that they can find science in their everyday life. Believe it or not, we actually do have science that does affect our everyday life. And I give some examples here from saturated lipids found in your Cheetos to albumin protein in your eggs. This is all a part of science. Also, the Newtonian mechanics and how they are applied to driving, which is a good thing. Otherwise, we might have some other type of physics, like collisions, that could happen. It is also in the chemical composition of makeup, which, if you're anything like me, you apply it religiously every morning. So science is really everywhere. But the key is finding what is science and then what is kind of using science's name, but not really science. And so I like to call this phrase when pseudoscience attacks. And pseudoscience, in essence, is something that looks like science, it kind of tastes like science, it smells like science, but it's not actually science. It is false science, and it hides behind the name of science. So as students, as my students, I try and open their eyes to things that are science versus pseudoscience. And it's also important that society has a keen eye. So let's talk about some examples of pseudoscience. So I start out with movie science. Hollywood is infamous for trying to add science in to a lot of their movies. However, they don't always get it right. And I ask the question, the simple question, can sound really be heard in space? And if you know anything about science and the way that sound is actually propagated, you have to have a medium in order for sound to travel. And if you're in space, well, that doesn't actually happen since space is supposed to be a vacuum. But if you watch movies like Star Trek, which I have a clip here, you'll notice that they like to add in a lot of really cool sound effects that seem like it should happen, but they probably wouldn't if you're actually in space. So let's watch it here.
Do not drop those shields, Mr. Sulu.
Captain, given your awareness of Khan's true location in the med bay, may I know the details of your plan?
I told Marcus we were bringing a fugitive back to Earth. That's what we're going to do. Mr. Chekhov, can we warp?
Sir, if we go to warp, we run the risk of seriously damaging the core.
Can we do it?
Technically, yes, but I would not advise it, Captain.
Noted. Mr. Sulu, set course for Earth.
Yes, sir.
Punch it.
Okay, so as you can hear it, as they're zooming off or punching it off at warp speed, you can kind of hear all the sound effects that probably wouldn't happen. Another one I made mention of is the movie The Core, where apparently a team of scientists and researchers were able to make it to the center of the Earth, which is pretty unfathomable as it on its own. But if you were to take it further, which they do in the movie, they show that these people can actually propagate radio waves while in the core of the Earth, which I find really amusing because sometimes I can't even get cell phone signals on my campus, and I'm on the surface of the Earth. So the fact that they think they can get radio waves in the center is just pretty interesting. So the next is astrology and UFOs. So about 31% of Americans actually believe that the stars can tell their future. And this is absolutely a big pseudoscience that many people fall into the trap of. And I really love the way that Bill Nye debunks this. And I have a little clip here that he says it the best. So I'm going to show it here and to explain.
You believe in astrology?
A little bit.
What makes you say that?
Because I can see the stars.
You probably know your sign. Or do you? Try this. Wait for your birthday, then stay up all night. And watch where the sun rises. It will pass in front of one of the 12 constellations of the zodiac. They say, I am a Sagittarius. So on my birthday, you might expect the sun to rise in the constellation Sagittarius. And it did. 2,000 years ago, when the Babylonians made all this up. But it doesn't now. In the last 2,000 years, the Earth has wobbled like a top. So now on my birthday, the sun rises in Scorpio, not Sagittarius. So maybe you'd have to be a Capricorn to be a Sagittarius, and Scorpios would have to be Libras. See, astrologers are off one full sign. In 2,000 more years, they'll be off 2 signs. But they don't seem to care. So, in these reflective moments, I ask myself, am I a fun-loving Sagittarius or a sexy Scorpio?
So the other part that I wanted to mention deals with alien invasions of planet Earth and the government covering it up under Area 51 and all of these other things. These are actually not science-based. Many of them is just suspicion and speculation. And I put a picture up here of a crop circle, a very elaborate one, and I found this website of these guys that actually create the crop circles. They're called circlemakers.org, and if you log on to the website, they actually go into detail of how they do it and why they do it and how they can really fool people with their elaborate circles and schemes. The next, and probably everybody's favorite, is the paranormal. Whether you believe in it or not is up to you. However, from a scientific standpoint, we don't give paranormal activity a lot of credit. And part of the reason is because it's very subjective. You could have a sort of experience or an out-of-body experience or something could have happened to you. However, just because it happened to you doesn't mean that it could be duplicated or replicated and happen to me. And because it's very spotty in nature and it does not allow a lot of testable scenarios, it's seen as a pseudoscience. And believe it or not, 3 out of 4 Americans actually believe in paranormal activity, and this was based on a Gallup poll in 2005, which I find extremely interesting. Finally, probably one of my favorites is cryptozoology. I have an image here that actually gives some cryptids that are very common that people look for today. We have unicorns, Sasquatch, the Loch Ness Monster, mermaids, the Yeti monster, you name it. All of these are what we call cryptids because they're not actual creatures. However, people do believe that they are out there and that there is a science to tracking down cryptids, and in reality we call this a pseudoscience. And there was a poll that was put out, or a survey I should say, put on by Baylor University in Waco, Texas, and they actually surveyed the population out there and asked them a couple of questions, or a series of questions about pseudoscience and the nature of it. And one of the questions that I loved from the survey, I pulled it here, it says, creatures such as Bigfoot and the Loch Ness Monster will one day be discovered by science. And about 17% of the population actually agreed with this statement, and 27% of it was actually undecided. So there are many people out there that actually believe these things are around. I thought there was actually an interesting follow-up study to this that showed those of the people who actually agreed that this would happen and science would discover these, about 33.4% of them had a high school diploma or less, or lower in degrees. And of the ones that actually were against it, about 18% of them had at least a bachelor's degree or higher. And the poll more or less took from this that the more educated you are, the less you believe in pseudoscience. And so finally, what I wanted my students to get away from this and to get out of this is, just because something looks like it could possibly be science doesn't mean that it actually is. And so I have my students oftentimes ask themselves, is this science or is it a sales pitch? You know, who's actually gaining from the knowledge that is being discovered or disclosed to the public? If it's some sort of industry or something, and it seems like they're getting a gain out of it, it's probably a trap or a pseudoscience. Also, when you're looking at articles or advertisements, check out the data. Does the data make sense, and is there enough of it? And what I mean from that, a lot of articles and advertisement for diet pills, miracle diet pills and things like that, and they show all of these really flashy graphs. But when you really delve into looking at the graph, you'll notice that a lot of it has been changed and altered from like a scaling standpoint to really kind of change the data to make it look like something significant has happened, when in reality it hasn't. So I always tell my students to really, really look carefully when they're observing articles and data. And then finally, does the science make sense? If it seems too good to be true, it probably is. Or if the science just doesn't make sense, the mechanism behind it, it might be not actually science. So if you're ever concerned or you're not sure, always check with an expert. And what I like my students to do is I want to get them excited about science, and I want them to look for it. And so what I would like them to do is pick a topic that they enjoy the best, or something that they think is possibly science but they're not sure, and I want them to do their research, analyze articles or data, gather information about it, and then make a podcast so that all of their peers can kind of see what their findings are about. Because I promise, if they're interested in it, then most likely their peers are going to be interested in it as well. And so what I would want them to do is then share their podcasts on like a science forum page that other students can come and watch their videos and make comments, and really just build a collaborative science community about the nature of science and what makes something science.